Hey folks, welcome back to the discussion on conic sections. This is going to be our last video in this particular set of notes. So if you'll go all the way down to the hyperbola so that we can get an overview of that particular conic section. I bet you can guess what the center is going to be. That's going to be at HK. You'll notice that I have two hyperbolas here. One of them opens right and left, and the second one opens up and down. I did not mark all of the pieces on both, but they all have the same set of labels. So let's go ahead here and just zoom in on our labels on this first picture. You notice that I have the center marked. The vertices are kind of like, they look a lot like the vertex on a parabola. The focus points, there's two of those. The focus points are inside the hyperbola, kind of like it was on the parabola. You'll notice that there are two different axes that we have, and I believe I have those marked over here on this picture. So the axis that connects the two vertices, this is going to be called the transverse axis. The other axis is called the conjugate axis. And what's important about these two, if you understand what these two axes are and how to get them, then it's going to give you the box that you see. That box is called the reference rectangle. It will give you that box, and if you can get the box, then you're going to be able to draw your hyperbola fairly easily. Let's go back to that other one. We've got, notice the end points of the conjugate axis are marked. And the vertices are going to be the ends of the transverse axis. So that's going to be the pieces of the hyperbola. Now let's take a look at the standard equations of the hyperbola. The first standard equation, this is the one that opens right and left, is going to be x minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. And the one that opens up and down, wow, that looks really, really similar. So take a look at it, and what do you feel like looks different about that? Okay, yeah, the y's are now written first, and the x's are written second. What I like to focus on is the fraction that is the positive fraction. So when it's the x fraction that's the positive fraction, notice that the y fraction is the negative fraction because it has a minus sign in front of it. When the x fraction is the positive fraction, it opens right and left along the x's. And when the y fraction is positive, it opens up and down along the y's. So that's how you use your two different standard equations. Now, here's the question that I'd like for you to write down the answer to be ready to turn in for credit. What similarities, and there are several, what similarities do you notice between the ellipse and the hyperbola? So once you finish this video, go back and look through your notes on the ellipse, look through your notes on the hyperbola, and what similarities, list the similarities that you see on the hyperbola when compared to the ellipse. All right, continuing on, let's talk about this transverse axis. I already mentioned it. It's got 5 special points on it. It always has the value A on it, and it helps us make our reference rectangle, that box in the center. The conjugate axis always has B on it, and it also will help us to make our reference rectangle. Distance A is always going to be the distance from the center to the vertex. Distance B will always be the distance from the center to the end of the conjugate axis. Distance C will always be the distance from the center to the focus. Now, I didn't mark those on the picture, but that would be very simple to mark that right here. So from the vertex to the center, this is going to be distance A. From the vertex to the end of the conjugate, this is going to be distance B. And from the center to the focus, this is going to be distance C. All right, and continuing on then with a couple more things about the hyperbola. Little dude, again, don't use that as an official term. This is just something that I tend to use in class. So little dude in this case is going to be a squared plus b squared equals c squared. And you're always going to use this guy when you are working with a foci. The vertices are always going to be A away from the center. The ends of the conjugate axis are always going to be B away from the center. And the foci are always going to be C away from the center.